Alrighty, chapter 5, notes, igneous rocks. It's about igneous rocks. I know this says chapter 2 up here. Ignore that, okay, because this is from a different book, a little bit better book than the one we're using. And it just simply is going to start out, look, if you're going to know about igneous rocks, you have to know the rock cycle, okay, which they tend to skip over here. So rocks are any solid mass of mineral or mineral-like matter occurring naturally as part of our planet. Remember, we studied minerals. When I take minerals, it's just like when you make a snowball. You pick a snowball up, you scoop up the snow, and you got to pack it, right? You got to pack it to make that snowball. So as you're packing the snowball, you're taking, rocks are the same way. They take a handful of minerals and they pack it together and then make a solid mass. Okay, so it's a handful of minerals or a big scoop of minerals crushed together like you crush together a snowball. And as you will see as we go along, even water can add to that snowball. Water can add to a rock and how rocks are formed. So anyway, the rock cycle, the first is the type of rocks. Igneous rocks is formed by the crystallization of molten magma. There are sedimentary rocks. It's formed by weathered products of pre-existing rocks that have been transported, deposited, compacted, and cemented. We're going to talk about sedimentary rocks. Next, there's a chapter on sedimentary rocks. Then metamorphic rocks. We're going to talk about those. Metamorphic is formed by the alteration of pre-existing rock deep within Earth, but still in the solid state by heat, pressure, and or chemically active fluids. The rock cycle shows the interrelationships among three rock types: igneous, sedimentary, and metamorphic. Magma, which is what we're talking about at the beginning of this first section, magma is molten material that forms deep beneath the Earth's surface. Lava is magma that reaches the surface. Weathering is a process in which rocks are broken down by water, air, and other living things. And sediment is weathered pieces of Earth elements. All right, here's the rock cycle. Rocks at Earth's surface are broken down into smaller pieces called sediments. Then sedimentary rock are formed. We can get metamorphic rock, but this is what I really want to look at: the igneous rock. When magma or lava cools and solidifies, igneous rock form. Now, this always is in process. Each one of these steps is active at all times. Okay. Active at all times. We're going to look at the igneous rock right now. Energy that drives the rock cycle processes by heat from the Earth's interior. If you watch the first lecture, you know that that radioactive material in the Earth's core, in the Earth's mantle, heats that rock up and turns it into a liquid magma. All right. Earth's interior are responsible for forming both igneous and metamorphic rock. Weathering and the movement of weathered materials are external processes powered by energy from the sun, and external process produce sedimentary rocks. Here we go. Formation of igneous rocks. Intrusive igneous rocks are formed when magma hardens beneath Earth's surface. When lava comes out and forms rocks, when that lava comes out, it's intrusive. They're formed when lava hardens. Intrusive, that means inside the Earth. That magma hardens inside the Earth's surface. Remember again, magma and lava are the same thing, but magma is under Earth's surface. Lava is out on top of the Earth's surface. Okay, so igneous, intrusive inside the Earth, and extrusive outside or exiting the Earth. Classification of igneous rocks. Igneous rocks can be classified based on their composition and texture. Texture is coarse-grained texture is caused by slow cooling, resulting in larger crystals. Fine-grained texture is caused by rapid cooling, resulting in smaller interconnected mineral grains. So the minerals, depending on how long the magma has to cool, the lava has to cool. How long it cools gives me larger crystals. Here's a couple of examples. Okay, so these two rocks we're going to look at here are Um, the exact same minerals. They're made up. Let me just go to the next one. These are made up of the same minerals, the same exact minerals. The difference here is this had a longer time to cool. That's why the crystals are larger. There's larger crystals because it cooled over a longer period of time. This is called coarse-grained igneous texture. This is a fine-grained igneous texture. Again, it's weird to think that these are the exact same minerals, but this one cooled much more swiftly. And since it cooled faster, it has a fine-grained igneous texture. Texture. It could be glassy texture, and this is caused by even more rapid cooling. Let's take a look at that glass, volcanic glass. Look at it. It's glassy, all right? And it's because it cooled so fast, crystals didn't even form. So when we're talking about igneous rocks texture, you can have a glassy texture. Porphyritic texture is caused by different rates of cooling, resulting in varied size minerals. Do I have a porphyritic? I do. Here is porphyritic right here. Look at porphyritic. I have fine grain mixed in with coarse grain. This is porphyritic. It started cooling really slow, and then all of a sudden, boom, it cooled really fast. It changed its cooling process. It started cooling slow. That's where the bigger grains come from. And then it increased its cooling rate, which caused the fine grains in there. Okay. So that's porphyritic. Is caused by different rates of cooling, resulting in various size of minerals. Composition. Is it a granitic composition? Rocks are made mostly of light-colored quartz and feldspar. That is what we have back. Whoop, I'm going the wrong way. That's what we have right here. These are granitic. Granitic. They have light-colored materials. Okay, lighter colored materials, light colored quartz and feldspars. The feldspars are the pink and the yellows, while quartz is the white or the purplies and the reds. But they are a lighter color. All right. Again, here's the glassy texture. This is called obsidian. Okay. Rare obsidian is pure black with white flecks in it. It's called snow obsidian. It looks like there's little white snowflakes in the obsidian. It's pretty cool. Rather rare. Here's your porphyritic texture. Okay. Classification of igneous rocks continued. After, let's go back here. I'm going to go back and I'm going to flip back and forth between these. Texture, composition. All right. It looks like I might have messed up my numbering system here. Nope. Composition. Basaltic composition. Rocks are made mostly of dark colored materials like plagioclase, feldspar, and silicate. Andesitic composition rocks are between granitic light color minerals and basaltic composition dark color. So you're looking at like the light grays. For andesitic. Basaltic is just dark as can be. Here's some basaltic. Look at how dark it is. This is just, we call it basalt. It's just a generic term for volcanic rock that has a dark color. Volcanic rock, or I should say igneous rock. Igneous rock of a dark color is called basalt. And the lighter colored, like this, is granitic. Ultramafic composition rocks are made mostly from iron and magnesium-rich minerals. Ultramafic are going to be an orange color. All right, they're going to have orange and red in it. The more iron that's in a rock or magnesium, the more red or orange that rock will be. Again, basalt. And then here's in the second homework, you have a table similar to this. All right. Chemical compositions, granitic, andesitic, basaltic, and ultramafic. And it shows the type of materials that are in there, or minerals, I'm sorry, Dominant minerals are quartz, potassium feldspar, sodium, plagioclase feldspar. These are the lighter colors. Okay, these are going to be lighter colors. And acidic are the medium colors. Amphibole, sodium, calcium-rich, plagioclase feldspars. The coarse grain, if you find a coarse grain, middle of the road color rock, a medium color, not real dark, not real light, and it has coarse grains, it'll be diorite. Okay. Actually, let's just look right here. This might even be more helpful. Coarse grain, granitic, fine grain, rhyolite. Check this out. Guess what? Piece of granite. It's a coarse grain igneous texture. Rhyolite. This is rhyolite. It's the same thing, but it is a fine grain. So if we jump again to that last slide, you will see a fine grain, granitic. It's light colored. It's rhyolite. If it's a heavier grain, right there. If it's porphyritic, it will be an obsidian. Okay, it'll be obsidian. I'm sorry, glassy is obsidian. My bad. Porphyritic is going to look like this other one right here. All right. See the light colors in it. This is even a gray or a lighter gray. I'm going to tell you because of that, the lighter pink color in there, it's going to be granitic. And it would fall, it would fall into that other category there. Let's pull this back up. Cider clicked one too many times. Right here. All right. Here's your, and then your glassy, your obsidian. Pumice is also, we're talking basaltic. You're going to get a pumice, which is a really rough stone. I wish we were at school so I could show you this. Here's your rock colors, 85% to 100% darkness, ultramafic, 45 to 85 basaltic. If it's going to fall in this range, we have andesite. So that's how you read this chart. Okay, that's how this chart is read. That'll help you with your homework also in section 2. Okay.